Okay, this is what I want to work on now. This is physical science paper 1 there. This one is from the 2025 June question paper of the Gauteng paper. Ne? So they say that you are given circuit A and circuit B are connected as shown below. We can see that, and they say both circuits, the same battery is used, and all resistors are identical. All of them, they have the resistor of 3. All of them, R1, R2, R3. Even on that circuit B, R1, R2, and R3. All of them, they have the 3 resistor. Let me just go and put that on there. Let me go and put that on the drawing so that you guys don't forget this. Right? So this one is also 3. The resistor of this one is also 3. Then this is 3. This is 3. This is 3. Okay, so they said the battery has the EMF and the internal resistor of an unknown value. The voltmeter and the ammeter readings are indicated. Okay, first question. Define what is power. Okay, you can write the formula down for power. Use that formula to define it. Ne? So it's the rate at which work is done. Power is the rate and that's the formula for power. Question 2 for circuit A. So we only focus on circuit A to answer 9.2, not question 2. 9.2, we only have to focus on that circuit A. What will be the current through the resistor R2? Guys, look at this. R1 and R2 are connected in what? In series. So I just want to explain something there. This is your I total. This is your total resistor, which R1 will read the total resistor of 2.4 amperes. Right. But now, remember what happens when the total resistor goes into resistors that are connected in series. The resistor will divide according to the resistors. Oh, the current will divide according to the resistors. Okay. But in this case, I don't want to go into too much details because we can see that these two resistors are equal. So this total resistor, it will be divided into 2 equal parts. So each resistor will read 1.2 amperes. Each resistor will read 1.2 amperes. So I don't want to waste time on that. They say that what will be the current through R2? So R2 will read 1.2 amperes. So this tells you that the 2.4, it will be divided into 1.2 and 1.2. Okay, so now remember that the current moves from the positive one. So you just have to check between this guy and that guy. Which one is the bigger one? The bigger one is positive, the small one is negative. So the current moves in that direction. So this tells you that this, when the current gets to that point, it will divide. Then the 1.2 will go that side. Then the 1.2 will go this side. So on some of my upcoming lessons, I'll explain how will the currents divide if the resistors are different. But in this lesson, I just want us to only focus on what we are given, because if I give you too much information, you'll be confused on what we are currently working on. Okay, so now they want us to the next one, 9.2.2. So on 9.2.2, they say calculate the power dissipated by both R2 and R3. We are still in circuit A. And let's say you don't know what is going on the question. You don't have to understand, but let me teach you what you need to do if you don't know what is going on there. So I'm going to say power. They want me to calculate power. We know that power is P. And then I'll go on the formula sheet. I'll definitely go to some of the past papers. Maybe go to the formula sheet. Let me quickly go to the formula sheet of this question paper. And then I'll go where it talks about the electric circuit. I'll indicate all the formulas that have P. This is the formula for 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 P. Then now you don't know which formula you need to use yet. Then let me help you how to choose the formula. Okay, so when I go back this side, the set calculate the power in both R2 and R3. I'll look at what I have in that R2 and R3. So now look at this. I know that R2 and R3, they will read the total current of that 2.4. So I'm going to write this down, that the I total for these two guys, the R total for these two guys is going to be 2.4 amperes. So this is what I know so far. And then both of them, they will have the voltage of, you see this voltage is for both R1, is for both R3 and R2. So they have the V of 3.6. So this is what I know so far. Then I'll go and choose the formula that has the I for current and V for voltage. I for current, V for voltage. I can use that formula, and then I'll explain if, let's say, you want to use this one. We're coming to that, but the easiest one is to take what you are given, which is the voltage and the current, and I'll definitely use that one. Let me quickly do my substitution. So to calculate the power, I'm going to say P is equals to we set VI. Then you just have to substitute what you were given. We know that we set that the voltage, that's 3.6, and then the current is 2.4. Then you going to punch that on the calculator, see what you get when you punch the 2. So it's going to be 3.6, which is multiplied by 2.4. So this gives me an answer of 8.64. So that will be my power. So the power is 8.64 watts. So now let me indicate okay, first thing first, the formula, important, there's a mark for the formula, right? And then for the substitution mark, and then for the final answer mark. So now I know this looks like this is an easy problem to work on, but when you look at the final answer, let's say you forget to write down U because you don't remember the SI unit for power, then you're going to lose the mark. You can't say 8.64. What are you talking about? What is this 8.64 for? So always in physics, the final mark should have an SI unit. Okay, so and that's there are some of the questions where the final mark should not have an SI unit. For example, the coefficient of static friction, the coefficient of kinetic friction. You see, the coefficient doesn't have an SI unit. Okay, so now this will be the formula. There's a mark for formula, mark for the substitution, right? So now another one that we can use, let me say maybe you prefer to use this question, P is equal to I squared times R, or you can go for this guy. You can also go for this guy because these two formulas, we have the current, we have the V. So let me explain what you need to do. The only thing that is missing is the resistance, is the R total. But when I go to the question, they said the power dissipated in what? R2 and R1. So you'll need to find the total current on what? The total current for R2 and R1. And if I look at that, they are connected in series. So it's going to be 1 over R, it's equals to 1 over the first one, we add the second one. So if you choose to use those two formulas, you'll have to first calculate the total resistance for those two currents. And then when you do the substitution, this will be 1 over both of them are 3, and this will give us 1 over R to be 1 over R8, guys. I'm sorry. I think I'm going to use a calculator for this, but I think this will be 2 over 3. Ne? This will be 2 over 3. Yeah, I think that's 2 over 3. 1 over 3 plus 3, that's 2 over 3. And then, okay, we're going to add 1 over 3. This gives us 2 over 3. So this tells you that the 1 over R is 2 over 3. Therefore, you can conclude and say R will be the reciprocal of that which is 3 over 2, and R will be just 1.5. So this is the total resistor for those two resistance. And then if you choose to use that formula, one of those two formulas, let's start with the first one. We can start with this one and see what we get. So I think that should give you the same answer. So this will be power is equals to, let's start with the one that says V squared over R. So the voltage we set is 3.6. This will be 3.6 squared. Divide that by R, which is 1.5. And this should give you the same answer of 8.64. You can also confirm that on your calculator. Then let's say maybe someone preferred to use this one. Power is equal to the current squared R. So the current we set, the total current is 2.4 squared, then into 1.5. This should also give you that same answer. Right, I'm just going to move to 9.3. So on 9.3, we're going to focus on second B. First question, 9.3.1. Calculate the energy that is used for resistor R1 if the current flows for 10 minutes. Remember, I said even if you don't understand what is going on the second, you can still get the questions right. Just look at what they are looking for. The energy. What is the symbol for energy in physics? The symbol for energy is W. The symbol for power is P. Then you'll go to your formula sheet, look for all the formulas that has W. You tick all those formulas. Okay? Then you're going to choose the formula that has what you already know. The set for resistor R1. We know that R1, resistor R1 is equal to 3 ohms. Okay, so if the current flows for 10 minutes, and then we are given delta T, which is 10 minutes. Remember, when we calculate energy, the time should be in seconds. So we need to take that 10 minutes, convert it in seconds. So we know that 1 minute has 60 seconds. So we can take the 10, multiply by 60, and see what you get. So this will be 600. So that's what I'm going to do. Immediately when I see minutes, I convert so that I don't forget to convert that. So this will be 600 seconds. Then I have the resistor, I have delta T. Let me go and look at my formulas. I have the resistor, I have delta T, and then which formula will work? So let me start with the first one. This one won't work because I don't have the charge there. And then looking at the next one, I have the voltage, I have the current, I have delta T. So this one can work. Look at this one. I have the current, I have the okay, will this work? We have the current. Do we have the current for R1? Yes, I think we do have the current and the resistance, the time. That will also work. And then even this one will work. So I'm just going to choose any of these formulas to find what I'm looking for. So let me take the first. Maybe I can go with which one? Okay, let me just choose the formula that I'll go with. Maybe this one, because all these formulas will give me the correct answer. So now I'm just gonna just work it out here and say the energy is equals to the current squared, the resistance times the time. Then you just have to substitute the current on R1. So remember we said when I look at this, what was the question? Calculate or the energy used for R1. Okay, so I know that for R1 the resistance is 3. And what is the current? Oh, guys, I'm so sorry. We are on circuit B. I can see that we are on circuit B. So the R1 is this one. And now what will be the current for R1? So look at this. The total current is 1.26. So all these resistors will read the same current. All of them. They will read the same current because they are connected in what? They are connected in series. All of them, they will read the same current. So now I know that the current for R1 is 1.26. for that 3 resistors. So I can just substitute and say this is 1.26. This is squared multiplied by the resistor, which is 3. The time is 600. Then you punch that on the calculator. Let me see what is that giving us. So this will be 1.26, which is squared multiplied by 3, and then multiply that by, I think this is going to give us a very big number. Okay, let's see. This gives us 2857.68 if we round that off already, or it's already rounded off. Okay, so this will be 2857.68 joules. So also indicate the SI unit for that, because when they mark, they'll give you a mark for the formula, mark for the substitution, and a mark for the final answer. Right, going to the next one. How will the current be affected if R1 bent out and was not removed? So this guy, this is bent out, but it is not removed from the, it is not removed from what? It is not removed from the circuit. So remember we said that the bigger one, it will be positive, and the small one, it will be negative. And then we said current move from positive to negative. So this tells you that current will be stuck here. It won't be able to pass through those other resistors. So the current will be stuck. So what happens? Right only increase, decrease, or remain the same. We need to focus on how will the current be affected. So no current will go through the circuit. This tells you that the current will decrease. Okay, as there will be no current that is going into the circuit. And gives you, they want you to give a reason. You're going to say, since that one is blocked out, no current will go through. Will go through the circuit. Right. So now, if there is no current that will go through the circuit, what will happen is that the voltmeter, we know that the voltmeter has what? The voltmeter has a high resistance and will not let current pass through. So the voltmeter has, the reason that the current won't pass through is because the voltmeter has a high resistance and it will not let the current pass through. 9.4, they want you to define the EMF. So EMF, this is the maximum energy provided, or you can say the work done by a battery per unit charge. So the EMF is the work done, this is the work done by the EMF, the work done by the battery per unit charge. Per unit charge passing through it. Okay, I'm very sorry guys about the writing there. Through it. So last question, 6 marks. Why is this question 6 marks? Let's see what is going on this question. Because once it says 6 marks, there's too much work to be done because of the mark allocation. Resistor R1 is replaced by a new 3 resistor. Oh, so remember we said that this resistor is bent out, then now it is replaced. So meaning that it's back, we have a new resistor, it's back. So now when it is replaced, let's see what they want us to do. So we have the that resistor back, the one that was removed, is back. So now they want us to calculate the EMF and the internal resistor of the battery used in circuit A and circuit B. So let's say that I know that the formula for EMF, you'll get this formula at the back of your question paper. Let me just go on and also remind myself of the formula. The formula of EMF, E is equals to the current into R times the internal resistor. So E is equals to the current into R plus small r. So by looking at the question wants us to find EMF, which is something, this won't be easy for us to do because we don't have the internal resistor. We need to first find the internal resistor. How are we going to find the internal resistor? We can say, okay, when I look at this, okay, go back to, I just want to find a way because this looks like more complicated. Let me go back to the diagram because if I don't have this, I can use simultaneous equation. I can use the EMF of this battery and that battery, but I'm not sure if I'm on the safe side to do that. Then I go back and check. So first thing first, I look at the batteries. Okay, the batteries look similar, and then in both circuits the same battery. Okay, nice. Look at this statement. Wow, this is good. Right, you see, it's, even when I was still in high school, when I do feel question and there's something that doesn't make sense, I go back to the statement. Look at this. I'm looking for where they are talking about the battery. We know that EMF has to do with the battery, right? So they say the same battery is used. So E for this, E for A, it's equals to E for B. Then this gives me the right to just equate the two. So I'm going to first form an equation from circuit A. For A, what will be the internal, the EMF? So EMF is equals to, I'm going to use this formula and substitute. So the current, we know that the total current for that one, we said for A, the total current is just 2.4. So I'm going to sub in that 2.4. Remember, the 2.4 is multiplied by the R. We need the total resistance. Né? So the total resistance we add is going to be R1. Then we add the total R for parallel. So it's going to be R of series plus the R of parallel. And we just calculated the R of parallel to be 1.5. So we're going to take the 3, we added that with 1.5, which gives us 4.5. So the total resistance for A is 4.5. Remember, this R is your R, this is your R total. So this will be 4.5. Okay, we take that 4.5, we add it with small r. Then I'm going to equate and say this is my equation 1. And then I'm going to do the same for B. E is equals to, for B, I'm going to say E is equal to the total current for B. It was 1 point something. So the total current 1.26. Then let me go and sub in that value. So this is 1.26 into the total resistance. We just have to add all this resistance. So it's going to be, the total will be R1 plus R2 plus R3 since they are connected in series. So it will be 3 plus 3 plus 3, which gives us 9. So this will be 9 plus R. Then we said that the EMF is the same. This will be my equation 2. We said that the EMF is the same for both circuits. So we can equate the two equations and say 2.4 into 4.5 plus R, it's equals to 1.26 into 9 plus R. I don't know the best way to do this, if you can multiply out of the brackets first, and or maybe you can just, I don't know. You know what? Let me just multiply the bracket this side and see what I get. 2.4 times 4.5. Okay, let's say 2.4 times 4.5, 2.4. I'm multiplying out the bracket with that 2.4. This gives me 10.8, so this will be 10.8 plus 2.4 times R, that's 2.4 R. It's equals to 1.26 times 9. 1.26 multiplied by 9. That gives us 11.34. So this will be 11.34 plus 1.26 R. So I'm going to take this 2.8 and move it to the other side. Né? So I'm going to take this 2.8, move it to that other side, take the 1.2 to this side. So what is that giving me? So this will give us, let's quickly work on that. This gives us 10.8. We subtract the, oh, we said that 10.8 will go to the other side. So this side, I still have 2.4. So from this 2.4, I need to subtract something, okay? So, okay. So I'm going to take the 2.4R, subtract 1.26R, because it goes to the other side to be negative. And then we take the 11.34, we subtract the 10.84. What is 2.4 minus 1.26? Let's see, 2.4 minus 1.26, that gives us 1.14. It's equals to 11.34 minus 10.8. That is equals to 0.54. This is R, 0.54. Divide both sides by that and to find R. So I'm going to divide the 0.54 by 1.14. So divide the answer by 1.14. This gives us an answer of the resistance to be 0.47. That's the resistance, 0.47 if we round it off, okay? So the internal resistance is 0.47 ohms. Okay, but now the question said find the value of EMF and the internal resistance. So already we have the internal resistance. We can just come back to this equation and do the substitution to find the final EMF. So the EMF, because the EMF will be the same for both of the circuits, so I can either use circuit A or we can use circuit B. So this will be the current for A. If I use A, the current will be 2.4, right? Into the total current for A, it will be 4.5, then plus R, which is the one that we calculated as 0.47. Right. So E is equal to, I just want to rewrite that equation, okay? 4.5 plus 0.47. Therefore, what is the EMF equals to? Let's go back to the calculator. 2.4 into 4.5. We add 0.47. 11.928. So the EMF is 11.928, and that's the answer. So guys, I need you to go and do this for me. Né? Please do this for me. So remember, E, it's a battery, so the answer should be in V. So guys, please do this for me. Remember, I just calculated the EMF using A. I need you to calculate the EMF using B. Drop in your comments and confirm with me if you get the same answers when you use B. So remember, when you use B, the current should be 1.24 and the total current should be 9. Please, 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 guys, go and confirm by substituting your internal resistance of 0.47 and tell me if you get the answer. I need to see you guys dropping all the comments. And if you don't get it right, if we don't get the same answer, then this will tell you that there's something wrong with whatever that we did. And that's it for this one.